So I'm starting now. So guys, today's topic, first one, will discuss about some architecture, which is an advanced architecture of F5 with discussion about more network architecture, like when we have layer 2 switch or when we have layer 3 switch between your load balancer and server, how the traffic flows. So yesterday we discussed about network connectivity. So from the understanding of yesterday class, we found that F5 should be reachable from servers, whether servers can be on premises or servers can be cloud. So we will see both the architecture now. And we have also seen that client was able to connect application hosted in these servers. So that was the yesterday discussion. Someone have some issues, we can discuss about the connectivity. One or two people were having issues importing the servers. We can discuss in Q&A. That's not an issue. But please understand the architecture diagram today. That is the main thing which we wanted to discuss. So yesterday, guys, I'll continue with yesterday architecture. First, we'll discuss again how your big IP software architecture is with network architecture. So when I talk about big IP, so we have an operating system which is called TMOS. For any troubleshooting issues, you should know what is the operating system. So this is one of the software architecture of big IP appliance, virtual editions or Viprion. So your F5 can be deployed in chassis level, simple big IP appliance or virtual editions in your production traffic. When I talk about TMOS, guys, TMOS is a Linux operating system and it has been divided into two planes, management plane and data plane. Very, very important. So what is the process? So you should know control plane, data plane and daemons. For any troubleshooting on any architecture, people can come. Like we know that there is a load balancing which F5 performs. We know that there is an health monitor. Yesterday we discussed about these terms. But what are the operating system which is running behind data processing? So when a client connects to your F5 and when F5 connects to your server, so this data forwarding is happening how? And what is the operating system behind that? That is called TMOS. TMOS simply means traffic management operating system. And it has a kernel, guys. It's a process that a daemon which has been used is called TMM. That implements all the big IP data plane. Like someone was asking how it decides it's on which server it should go. So it is based on your traffic management micro kernel. So traffic will come incoming from client and F5 will first check whether server is reachable or not. And it will forward the traffic based on load balancing algo. And the architecture or kernel which is used is called TMM, traffic management microkernel, guys. That is very, very important. You should understand what does TMM means. Because traffic management microkernel is the main kernel or process, I can say, that will implement your whole data plane traffic. And there are some other processes for WAF. There is a BD process. But this TMM is a mix of your OSI layer, which includes TCP IP, SSL, and HTTP, guys. You can deploy F5 as layer 4, layer 7 both. You can load balances based on layer 4 load balancer that will be segregated on virtual server, guys. When we'll discuss about types of virtual server, we discuss virtual server is a front end IP where traffic will first get hit. Always when there is a virtual server, then only F5 will start listening on your traffic. If there is no virtual server, F5 by default is a deny device, guys. That is the first objective. You should understand what is TMM and how the traffic flows. That is the architecture which is being defined by TMOS. So TMM is just an operating system process that will support all your data processing traffic from TCP to HTTP layer. Whether it's an SSL offloading traffic, whether in and out traffic it's going, that is done by data plane. Now, management plane, which process is being used? So there is a process called HMS. This is run on CentOS Linux operating system. Like someone was asking, hey, uh, when I do NTP, when I do some DNS configuration, SNMP, when you are accessing GUI and CLI, that is handled by which process? That is called HMS, Host Management Subsystem. So TMM is the core component for data plane. It handles all your network activities and communication. But your HMS, which is called Host Management Subsystem, it is running on your management plane, which manage your management traffic like CLI, when you access GUI, when you access DNS traffic, or when you configure SNMP, NTP communication. All is done by your HMS, and it is accessed through your dedicated management network interface. We have our management port for that. Guys, this is very important. This is advanced training which I am delivering. You will not find much details in Google or something. So you have to understand these two terms. This will be asked in a tech level interview. In exam, this type of questions might not ask, but we have a 301B where you need to understand these processes. So I will discuss one diagram where I'll show you how TMM load balancing happens. So TMM will have dedicated CPU and RAM. When you assign CPU RAM, it is allocated to your TMM. That is basically your software architecture where we discussed. Now, guys, we have discussed like big IP uses proxy architecture, and F5 as a big IP module is called your full proxy architecture. That we have discussed that there will be two TCP handshake, one from client to F5, one from F5 to server, guys. Now, next, what are your daemons which will be used? See, in data plane, this is the daemon. In troubleshooting, it will help you to troubleshoot your big IP daemons. Like in Palo Alto, you have daemons. In F5 also, you have daemons. For data plane traffic, in and out traffic from client to F5, F5 to the server, all your load balancing traffic will be handled by TMM. That is the core traffic manager. When I talk about cluster related configuration, that will be handled by HA configuration. That will be handled by clustered D. There is one more process which is used for health monitor. I was discussing yesterday, like when client wants to connect to one website, it comes to F5. F5 will first check whether which of the servers are up. If one of the server is down, it will not send traffic of that client to that server because it can cause internet issues. Some traffic of this client will go here. Let's say I have three clients. One client, the traffic F5 will send based on round robin to server one. But next client hits your same virtual server. Let's say website is 192.168 If health monitor is not there, then F5 can send traffic to this server because F5 does not have any visibility. You are making F5 intelligent, guys. So in that case, let's say F5 sends traffic to server 2. Will client able to access? No. clients, in this case, guys, you will face intermittent or slowness issues. That is the first troubleshooting steps you should do. How many of the servers are up? If someone reports that I'm not able to access the URL, you need to first check how many servers are being used and whether F5 is able to monitor it. Because F5 works as a full proxy, it will have two separate connection, client and server side. So in server side, it will load balance the traffic and make a decision based on load balancing algo. And another thing, it is using your host monitoring. First, it will check your which server is up. That is called health monitor. And what is the process which is used, guys? Big D. Very, very important, guys. So if I was discussing about traffic. I'll show you in my diagram like how the traffic flows. I will take one client side that I have shown you, but today discussion is about diagram flows, which I wanted to cover more. So I have F5. These are two clients. Okay. One I will say by red color, second I will say by blue color. Okay. This connection is called your client side connection, guys. Whenever client wants to connect to your virtual server, that is called your client side connection. It will be a separate three-way handshake, which will happen. It is not depending on F5 to server handshake. And when I talk about server side, it is downwards. This is your server side. When F5 will forward the traffic from F5 to server. In that case, let's say you have server one based on load balancing. So first, second, third, fourth, it will be your new TCP connection. So this is why it is called your full proxy architecture, guys. That is very, very important. There are two separate connections. I told you that this connection can be encrypted. Means client to F5 will be on HTTPS. But F5 to the server, it can be HTTP because that is called backend traffic. So client will establish a TCP connection to your virtual IP hosted on F5. And then it will send a HTTP GET request. First TCP handshake is done, then HTTP GET request will be sent. After that, once this connection is established, big IP will make a load balancing decision. You have three servers. Based on your load balancing decision, it will choose one of the servers. So it will observe that server 2 is offline. So it will choose connection between server 1 and server 3 only. And then HTTP GET request that was received will send final to your server. F5 has whole visibility. What is coming in a request header? That is called request. When client will initiate a connection to for your F5, it is called request traffic. When server will respond to F5, that is called response traffic, guys. That is why it is called request and response traffic, guys. This is how it is called two three-way handshake, which you need to understand. Now, I have simple diagram. I have client one, client two. Okay. Then I have this topology where I have, let's say, a router which is terminating your internet. Then let's say I have a layer 3 firewall. Then I have, let's say, layer 2 switch. Then switch will be connected to your F5. Then I have one layer 2 switch. Then I have servers connected to this. Please understand this diagram. You will understand everything. So this is called one of the deployment in F5, that is called two arm deployment. Why it is called two arm deployment, guys? Because F5 is using two interface, one for external traffic, one for internal traffic. That is called two arm deployment in F5. And there are two types. Either you have layer 2 switches or it can have layer 3 switches. I have seen both. So in this case, guys, you have, let's say there are here also two scenarios are there. Maybe all your servers are on same VLAN, let's say VLAN 10, and this external is on VLAN 20. In that case, guys, you will have two self IPs. This is live production. It can have, it's not on lab. It can have possible in your live environment also, that all your servers are in VLAN 10. In that case, guys, you need two self IPs. One for external and one for internal. Self IP, don't get confused. It is just a layer 3 IP, which is directly connected interface IP with layer 3 device. It is just a layer 3 IP assigned to VLAN, or you can say SVI. It will serve as a gateway. So self IP will be used here. So two VLANs, two self IPs. And you have two interfaces. One is external, one is internal. That is called two arm deployment. But here it can be scenario. This was one scenario which we discussed yesterday, when you have all your servers in same VLAN. And here you have one more self IP. Why? Because you have one firewall layer 3 interface. You need to have connectivity with each other. Or you can say self IP just an interface IP address, guys. In Palo Alto or FortiGate, you assign one IP to the VLAN, right? That is the same way here F5 has. So that is called interface IP address also. Some people can say interface IP address also. And it is also used in health monitoring, guys. When you have health monitoring concept, F5 will use this in monitoring your traffic. It will use your self IP. So self IP is associated with VLAN. Each big IP will have self IP in a VLAN. That is an IP defined in an interface. You can think like this. Now, this was one of the approach. Now, guys, there is one more approach which I'll show you. This is again a two-arm deployment. Okay, that I was discussing. Now here you can see one is front end connection and one is back end. F5 is only doing destination IP net translation. Your client IP will remain same. F5 IP will get translated to server IP that we have seen yesterday in our connection table. Now, can you see there are two interfaces which will be used by F5. One is called front end interface, another is called back end interface. That is called two arm mode architecture in F5. Very, very important in terms of interview or when we deploy the architecture. These are the deployment mode people can ask. What is the deployment mode in F5? So you have one arm mode versus two arm mode. Now, when I discuss further on, you will understand more. I need to discuss one more strategy here. Let's say your servers are in different VLAN. Your server 1 is VLAN 10, server 2 is VLAN 20, server 3 is VLAN 30. In that scenario, same scenario, how self IPs will be segregated, guys. I will draw the topology. Please understand carefully. You will understand. You have clients, you have F5, then you have one switch that is layer 2. And this interface is, let's say, 1.1, which is connected to switch. Switch interface, I will take Ethernet 0 by 3. You have server 2, server 1, server 3. Server 1 is in VLAN 10. IP is 192.168.10.1. Server 2, you have VLAN 20. IP is 192.168.20.2. Server 3 is in VLAN 30. IP is 192.168.30.3. Now, please understand that this interface will be access port or trunk port. Means, should I make this as a tagged port or untagged? First of all, this should be you should be clear about this. I have servers in multiple VLAN. I need to call multiple VLAN traffic on one interface. F5 has only one interface where I need to pass traffic of VLAN 10, 20, and 30. How I can do? I need to make it tagged interface. So that is called tagged interface. Why? Because I need to pass traffic of VLAN 10, 20, 30. Now guys, another thing. How many self IPs are needed in this case? When I will deploy an F5, how many self IPs will be needed here? Because I told you, you have multiple VLANs. Self IP is nothing but an layer 3 interface IP assigned to VLAN. I have 3 VLANs, so how many self IPs I need? Please understand the basics. Excellent, guys. 3 self IPs will be needed. For VLAN 10, I need one self IP because gateway of server will be F5 IP. So it should be from VLAN 10. So let's say from VLAN 10, I will assign one IP and server gateway of server 1 will be of this. From VLAN 20, I'll have one self IP that is called 20.100. From server 3, I'll have one self IP which is called 30.100. It will act as a gateway, guys. I self IP is needed where it will enable your F5 and other devices on the network to route application traffic. It is the IP that you associate with VLAN. Simple. Don't complex it, guys. It is just an interface IP address. It just represents your address space. Where you have range of IP where you can assign different host, server host. It will use as your default gateway for each destination server in each VLAN. So when traffic is sent to a destination server, guys, it will use your self IP of its VLAN to determine which VLAN I should send the traffic. Now I'll give you one example. Let's say I have one VLAN internal that has self IP 10.10.10.100. Okay, please understand this with net mask 255, 255, 255.0. And I have destination server behind F5 that IP is 10.10.10.20. Now, how F5 will recognize that client, it has multiple servers, okay, in different VLANs. How F5 will decide that I should send traffic on which VLAN? So big IP will recognize based on your server IP. It is falling in which VLAN range because it has external also, right? So F5 will check your server range because it has all visibility. So it will check, oh, 10.10.20 is coming under this. So I should use this IP address. And if you have one more than one interface assigned to the VLAN, guys, one more question for you. If you have more than one interface assigned to the VLAN, how it will check which interface I should send the traffic? It will be based on your MAC address table. Layer 2, or you can say layer 2 forwarding table. Now, one more scenario I will discuss. I have client, I have a firewall, I have a core switch, which is layer 3. Please understand this. I have F5. Then I'll have one more core switch. Now I'm talking about layer 3 switch coming into picture. Then I have multiple servers in same VLAN 10, 20, 30. Now layer 3 switch is coming into picture, guys. Now can someone tell me in this case how many self IPs will be required? I have server 1 in VLAN 10, server 2 in VLAN 20, server 3 at VLAN 30. I have core switch also, that is layer 3 connectivity is coming. Let's say this one is VLAN 10, this one is VLAN 50 between F5 and core switch. Now, can you tell me here how many self IPs will be needed? Please understand this, guys. You will understand everything in your network architecture. Can anyone tell me when layer 3 switch is coming into picture, what will happen? How many self IPs will be required in this case? You will understand you had a lot of confusion. And how F5 will reach to these servers? Because layer 3 is coming into picture. Your server gateway will be hosted where now? F5 or core switch? Two questions I have. Let's discuss. How many self IPs will be needed here? Let's understand your CCNA. What would be server gateway? Because layer 3 is coming into picture. What will be the server gateway? Third thing, this is clear that one interface self IP is needed here. But here, do I need four self IPs or one self IP will be needed? So let's see your answer. Suman, excellent. Sushant, excellent. It will be one self IP, guys. Self IP is a directly connected interface IP because F5 will have only connectivity till this. Can F5 directly? Third question I need to ask. How F5 will reach out to the server in this case? Because F5 wants to reach to servers, right? There is no L2 right now. There is an L3 coming. How F5 will, because for load balancing, there should be a reachability between F5 to the server. How F5 will reach out? Anything I need here? Come on, guys. Default route or static route. Excellent. If someone, because when L3 switch is coming into picture, so think of this as a Nexus switch or core switch layer 3. Then we have servers. Now there will two segregation, right? You will make three VLANs here now. Instead of F5, here you have to make three VLANs because one more L3 hop is added. But I need only one self IP, guys, between this and this. I don't need to take care of this. Whether server is in VLAN 10 or 20 or 30, who will take care in this case? Nexus switch or L3 switch. So here I will make three VLANs and server 1 gateway will be your Nexus VLAN 10, server 2 will be Nexus gateway VLAN 20, server 3 will be VLAN 30. And I need one self IP here because it is layer 3 IP. So let's say it is VLAN 50. So I will assign dot 1, dot 2 from one of the VLAN 50 subnet. Now when I am asking you one question here, F5 wants to reach to server 1. F5 needs to do load balancing, it should have a connectivity. So I need to add one route. How I can add route and what should be my gateway? Now let's say server gateway is 10.2.2.30. Now I need to add route in F5. What would be my gateway, guys? Can someone tell me? Even if I add default route, what would be my gateway? Next hop to reach to destination IP is clear. The destination IP is 10.10.2.30. What would be my gateway IP here? 50.2. Excellent. This interface. Simple, guys. This is a this is the 70% network architecture in your company. You will see this where between F5 to the server, either there will be layer 3 firewall or core switch comes into picture. Then you have one here also layer 3 switch. Then you have firewall. Then you have router and then client. So you need one self IP here only for external, that is the interface IP, and one self IP here. So self IP is a directly connected interface IP. It is just for building your network to send traffic to next hop. That is why we need self IP. If it is layer 2, then it will be from your server subnet. And that is called two arm mode architecture also, guys. Okay. And you need a route. So how to add route, guys? It's very simple. You don't need routing table much. Just log in into F5. I will show you. 137.60 admin admin password. I sometimes it's in habit, so it will be admin and then my password. So here you have a routes. So you have to build a routing table like this. Destination IP, your server IP. Let's say I will say route server. My destination IP I can give 10.2.2.0 net mask and gateway will be 10.2.2.2. This it can be that nexus switch gateway 10.3.3.2. So that is how your proxy comes into picture. When you have F5 as a proxy device, load balancer as your proxy device. So this is how your traffic policy will be. This is how your network when you have layer 2 and layer 3 into picture. That is how your topology is built. And you have two self IPs needed. One for external, one for internal. That's it. When there is a layer 3 device coming into picture. Now guys, what is the scenario of one arm mode? We have discussed two arm mode. What is the scenario in one arm mode deployment? In which case we should use one arm. This is where one arm comes into picture. I'll tell you the live scenario in which case we should use, but understand one arm mode. Can you see in two arm mode, one interface was used for external traffic and one interface was used for internal traffic. So incoming and outgoing was going through interfaces. Incoming was going through one interface and outgoing was connected to another interface. Now, when I talk about one arm mode, so both incoming and outgoing will use same interface of your F5. Single interface will be using for incoming and outgoing. This I will show you live. 60% some people deploy this, 40% they deploy two arm mode. But as per best practice guy, you should use two interfaces because one interface can use as a utilization issue. One interface because it's used for incoming and outgoing. Here can you see common subnet VLAN where your client and servers are. So here both your source and destination IP should be translated. That we'll discuss in SNAP concept. But one arm mode means single interface, see, only one interface. Your common network where both your clients and server will be connected. I will show you live production environment here now. Let's say guys, I have a client, then there is a firewall Palo Alto. Then there is a switch layer 2. Then there is a F5. Okay, then you have servers. Please understand this. Servers are hosted in AWS. F5 does not have any connectivity physically to this. They are not connected directly from F5. They are connected from firewall to switch and then server. Or maybe in cloud, I don't care. Because for me, F5, I care. How this servers in cloud connected to this firewall, I don't care much. But my dependency is someone wants to access some of the application on AWS through F5. Let's say Sianets.com is hosted on AWS and F5 is hosted in on premises. How F5 can reach it? Anyone can tell me? And why it is called one arm mode? If you understand this, your network concepts and F5 concepts will be cleared. My question is how F5 will reach out here in server? This server are hosted on cloud. So what will happen, guys? When client will hit a traffic to sianets.com, what will happen? It will use this interface. After that, what F5 will check? F5 will check server IP. F5 will say, oh, I don't have a connectivity. And even I don't know how to reach it. So what it will do? There will be one default route towards anyone firewall. So can you see this? Same interface will be used for incoming and same interface will be used for outgoing. That is called one arm mode architecture. Because F5 don't know how to reach server, but it will have a default route, it will forward to a firewall. Then firewall will be deciding how to forward. So through that, F5 has a reachability logically to server 1, server 2, server 3. So that is called one arm mode architecture, where incoming and outgoing is used by, sorry, same interface. This is live deployment, guys. You will see many cases like this, where you will see only single interface between F5 and firewall. You will only see one self IP. Plus, you will see default route. You will see only one interface, that is 1.1, and one HA. This is most of the major deployment which is happening nowadays. Because same interface, because F5 does not have this interface connectivity, right? F5 is again sending traffic to firewall. F5 says, I don't know, please send it to default route. Guys, what is the use of default route? Default route is only used when you don't have specific routing table. So you will just have F5 destination 0.0.0 with subnet mask 0.0.0.0 with this interface IP. Please trust me, guys, you will not see these scenarios on the internet. So you have to understand this carefully. This is one of the people will get in internet, you will get lot of confusion. But this is the, if you understand this live use case, then you can answer it. Okay, guys. Now, guys, I will show you one more thing. Two arm mode, just a definition. is where we can use more than one interface. Your IP should not be in same subnet of your physical servers. It can happen that your physical server default gateway is F5 and asymmetric routing is not possible. But if layer 3 is coming into picture, then asymmetric routing is coming into picture. That you will understand only by SNAT. That will explain later on. When I talk about one interface, only one interface of F5 will be used. And for physical server, see, that I told you, it is mostly your firewall or router. And asymmetric occurs without source net configured in F5 load balancer. That is how one ARM mode is deployed, guys. You can deploy this in existing technology, in existing deployment, because you don't need to do any changes in your network, right? You don't need to change your default gateway also in this case. And next thing I wanted to discuss was routing table. How routing is decided between your management interface and TMM interface. So big IP has two routing table by default. Big IP means F5 load balancer. One will be Linux routing table that will be handle your management networks, and one is for TMM for data plane traffic. One is Linux and one is TMM routing table. And big IP is by default a deny device without a listener. So guys, someone will say listener. Listener is nothing but a virtual IP. That is a simple thing of listener. And proxy, we have already discussed that you have big IP proxy allows big IP to visible your both connections. It has a whole visibility of your incoming, and you have two TCP handshake, client to F5 and F5 to the server. So they have independent TCP stacks on each side of your device. Right now, modern load balancers are like that. It can work as your SSL proxy. You can have encryption connection between client to F5 and unencrypted between F5 to the server. This is how, guys, a good diagram which I have taken, where your, let's say you have created a virtual server, how traffic flows. This is client and this is server. Your application is hosted in your server side. How the traffic flows. First, client will have a connection to virtual server. Then it will have TCP profile, layer 4. After that, there will be one SSL profile. So, guys, I will ask you one question here. When client wants to connect to HTTPS website, let's say I need to connect to HTTPS Sianets.com. Can you tell me the traffic flow in Wireshark? What will happen? Layer 1 to layer 7. Can anyone tell me? When client wants to connect to crnets.com, I will take one of the person. Ashwarya, please unmute, and you have the permission to unmute. Please tell me, when client wants to connect to crnets.com on HTTPS connection, how in OSI layer you will see the connections going. Ashwarya, please unmute. This will be a live questions in your interview and in production. When client wants to connect, you have done lot of networking, everyone. Even you are a fresher, you have done CCNA. I need to understand, when client wants to connect to HTTPS cnets.com, what will happen first? Ashwarya, please try. Don't, it's not a interview which I am taking. Please try. What will happen? Okay, Ashwarya, don't want to respond. I will please understand, guys. From this batch, I will select 5 mentors who I will give special coachings guidance after 4 5 months. They will be part of my excellent CEO team, where they will participate in different workshop. So if you answers rightly, if you participate, I, even if it's wrong, I don't care. But please answer it. I have a group, separate group from F5, where they participate on different issues of the company. So you don't want to participate, not issue. Deepak Proch, please unmute yourself. When client wants to connect to HTTPS through SSL, what will happen?
Yes, sir.
Yeah, Deepak, please go
Yeah,
ahead.
firstly, the client resolves the domain name to
Excellent.
the
So
IP
first
address.
you will say that DNS resolution is happening.
Yes,
Excellent.
and uh,
After that, DNS
after the,
resolution is successful. After
yes,
that,
then the client initiated TCP connection, like
excellent.
our.
What will happen in TCP? Can you tell me what is three-way handshake?
Firstly, it send the request,
What
acknowledgement, and
request?
request for 443
Packet.
port.
I need a packet header.
Yes,
TCP packet.
TCP
Three-way
packet.
handshake.
So
There is
it
a
will be,
packet.
yeah, yes, sir. So
What is the
after
name of that packet? There are TCP flags in your TCP
um,
layer. What are the flags? Do you know TCP flags?
yes, sir. Sync packet it will send.
Okay, correct. After that,
Sync it will, and then it will send the acknowledgement from the other side and the
no,
find.
Deepak, really sorry. Your TCP is not clear. How much experience you have?
I have 7 years.
Okay. Anyways, not an issue. There will be signal acknowledgement. Please
Yes.
get your TCP clear. And everyone, guys, it's not for Deepak, for me also. We need to be very expert in TCP layer if you want to be good in troubleshooting. I'll share you one book. You can study that. You can become expert. You have videos also available. We have a packet level training. So first, Deepak, it will be SYN. Then server will F5 will send acknowledgement. Okay, to client. Then client will send acknowledgement. That is called three-way handshake. Okay.
Yes. Yeah.
After that, can you tell me
After that, client and server established a secure connection on a
what is
SSL.
called that? What is that called?
Once the this the three-way handshake it's been established, and
After that,
it's a client hello packet it will send.
what is that handshake called?
A three-way handshake.
No problems.
TSL handshake you are saying, SSL handshake.
Correct.
Yeah, in SSL
The
handshake,
handshake will be sent.
yeah, it will send first
So
the
you
client hello packet.
correct. That is okay. That is
Okay,
okay.
okay.
A three-way handshake is done. After that, there will be an SSL handshake. You
SSL
should say
handshake.
SSL handshake.
Yeah,
Say, I need to
and
prepare you guys for interviews also. People will
yeah.
confuse a lot, Deepak. They will
Yes, yes,
ask you
right,
basic
right.
question and they will confuse you.
And once
After that, one SSL handshake is built then.
I think this certificate they'll validate.
Everything is completed, sir.
Okay.
SSL handshake means everything is completed.
Then once the handshake is completed, the
Please try. Not an issue.
STTP request and response.
Excellent. Very good. After that, there will be HTTP GET packet.
Yeah, HTTP get packet.
And
And,
after that,
lastly, if it's everything, it's in the connection termination. It will be done after that.
so there will be HTTP request. After
And
that, there
response.
will be response
Response from the
also.
server S. After this, yeah, the
Excellent.
client send an HTTPS request to the server, like the GET, for example, and the server processes the request and send an encrypted response back to the client.
It depends. If it is
Okay.
end-to-end, then it is encrypted. Otherwise, it will
Yes,
be
yes, yes. Right, right.
unencrypted.
In F5,
Now,
it's been
once,
spent.
but there something mistake you have done. You
Okay.
need to tell me in F5 point of view. No, this was the basic. That is correct. Now, when F5 is coming into picture, what will happen?
So if client send a request to the F5, like let's suppose so
In which,
443
where? In
VIP
virtual server, you need to say.
virtual cell. Okay, okay, in that way. Okay. So client
After
send a
that, there will
request.
be profile called
Yeah, it will.
TCP and SSL.
Yes, once we deployed the certificate, like it's SSL.
That we will
So
discuss later, Deepak ji.
okay,
That is
okay,
fine.
okay. Then SSL termination will be there, and there is a plain
Correct.
text
After
communication.
that, this is done. Now,
Yeah.
client to F5 three-way handshake is completed.
So
Now,
after
what will
that,
happen?
F5 send a request, send a traffic to the server on the plain text.
Where first there is no need of TCP handshake between F5 to the server.
Yeah, it will happen. The first it will be there. TCP handshake
So
between
you
the.
have to say that
Okay, okay.
there will be
Yeah.
one first three-way handshake is completed between client to F5, then there will be
Another handshake
see
between the
this.
F5 to the server.
No problem. Thank you so much, Deepak. At least you have tried. Great work. Now you can mute yourself. I will explain quickly. So, guys, there will be a TCP handshake which will be built between client to F5 first. So, client will send a SYN packet to your virtual server with layer 7 functionality. Then your load balancer will send SYNAC. Then finally, client will send acknowledgement packet. This is the default behavior when you are using layer 7 load balancer. In previous courses, I used to discuss this in later classes, but since it's a packet level training, I wanted to discuss advanced things also in beginning. Now, after Deepak ji and everyone, client handshake is completed. Can you see this? Client is sending one HTTP GET. After that, F5 will have three-way handshake with server. See this between F5 and server. LTM will send a SYN request. Pool member based on your load balancing algo. LTM will choose first pool member, then it will initiate a TCP connection. You have to take care of this term carefully. And this is not I am asking, this will be interview asking you these questions. After TCP, people say that TCP handshake is built. No. First HTTP GET is sent. Then LTM will choose pool member. So this is how traffic. First traffic, second traffic, third F5 will choose your pool member. Fourth, it will initiate TCP handshake. Now, fifth packet, the HTTP GET which was here, that packet will send finally to your pool member. That SSL handshake, don't worry, client hello, server hello. Everything we will discuss through Wireshark. How SSL handshake is built, that is the topic. But you need to understand how in load balancer full proxy architecture is followed. This diagram will help you. Okay, guys. So that is what it's showing here also. See this proxy is coming. There is a separate, this is called client side traffic. And this is called server side traffic. Same things, HTTP, SSL. If you want end to end, then you need both SSL. This is separate, but it does not have any dependency on this. That is what I wanted to show you, how packet flows in F5. Because it is called stateful network operating system, full proxy. It has all the flow aware. It knows what is coming in HTTP request response. It has whole visibility because it is sitting as middleman. It handles offloading. So what does offloading means, guys? SSL offloading, what does it means? You have seen this term many times. Offloading means previously server was doing all encryption and decryption. When F5 is coming into picture, it is called SSL offloading. It means all encryption and decryption will be done on F5 so that it reduces the load from server. So that was about TMM, TMOS, and how one arm mode works, how two arm mode works. And what is TMM process? What is it is happening? And this someone was asking about load balancing inside how it is doing it. Yesterday, someone was asking, let's say I have two members, two servers, server one, server two. How connections will be handled? So it is done by CMMP. There is a process called clustered multiprocessing. So in this case, what will happen, guys? Let's say if you have round robin algo. So it will have connection one. It will always goes to 10.0.0.1. Connection two. So you have by default 4 TMM instances. It depends based on that. You don't need to take care of these terms, guys. But I'm just telling you that CMP is a process which creates your separate TMM instances for each CPU. Like if you want to load balances based on CPU, here round robin, how connections will happen. See, can you see first 4 connections are handled by this. Then other 4 connections will be handled by other 4 TMM instances. By default, this is disabled. But if you want to distribute traffic, some people will say this is part of troubleshooting. Right now, we'll not discuss much on that. But by default, someone told me how it decides on which load server it goes based on your TMM. This is a kernel which is used to decide. That we will discuss later on CMP part. By default, you can think that TMM in CMP, it is disabled. That is called clustered multiprocessing. But we will see this architecture later on, like how TMOS works with CMP when user wants to access traffic on application. So each connection has 4 TMM instances that you can ignore as of now. It is an advanced thing that we will see, but this is how your TMOS architecture is. This diagram you have to take care. That F5 has capability of caching. F5 can do application security. F5 is not a load balancer, guys. It is more than a load balancer. It has a capability of WAF, SSL offloading it is. It can do rate shaping, caching, acceleration also it can done. It is a powerful networking microkernel. It can do I rules. Let's say I want that if someone is using iPhone, I should send traffic to server 1. If someone is using Android phone, that traffic should go to server 2. that we will see in our profile section. This is high performance hardware device. It helps you to deploy applications securely. Availability is 24 into 7 and fast. These are the three terms you need to remember. If I make sure that your applications are 24 into 7 availability, it is fully secure and it is fast. That was data plane architecture. Now, just 1 minute, I wanted to show you one last thing, then we will take Q&A session. Because network architecture was my agenda with live architecture. Just 1 minute. I need to show you one last diagram if I find it. Because I want that your basics should be clear. I don't want that someone comes and says that your basics are not cleared. Just 1 minute. So guys, this is in your live environment how the topology is built, where you have internet, you have your firewall, you have big IPs in HA, and you have see different VLANs, and you have pools segregated, and this is out of management interface also. Just a topology, another type of topology which is there. This one is external. This can be different networks like pool 2 and pool 4 is external facing applications. These are internal facing applications. You can think of that also. Can you see we have three IPs across each VLAN. VLAN 100. This is called which IP, guys? This 10.11 and 20.1. What is this IP? Can anyone tell me? If you can see VLAN 100 and VLAN 101, what is IP address? 20.1 and 10.11. This is called your floating IP. So questions in your exams can come like this. Simple in 101, you have 40% of your OSI and 60% will be F5. After 1 month, after this 12 or 13 classes, you can clear. It's my guarantee 101. I will help you to clear this. By December 31st, you can clear this exam. And please do it together because it's in huge demand. They will give you exhibit and they will tell you role of router firewall switch. Port lockdown they can ask you. So these are some of the questions from Blueprint. I'll share you this whole book after few classes. They can ask you to create self IP. So that was it, guys. I'll just stop recording for today.